Good morning students. Yesterday we had gone through rational numbers and the numbers in between any two rational number. Today we will go through irrational number. Yesterday I told you irrational number is that number which is not rational, and you know the rational number is the number where x is equal to p by q and p, q both are integers, q not equals to 0. If it is irrational, then a number x is irrational when x cannot be expressed in p by q form, where p and q are integers and q not equals to 0. Are you clear? If p by q is in the rational form, then PQ are integers and Q not equals to 0. Its reverse is our irrational numbers. Are you clear? Then root 2, root 3, pi, all these are irrational numbers. How can we locate root 2 or root 3 on the number line? Before this, you know how to locate integers, natural numbers, whole numbers and rational numbers on the number line. So just we will do locate root 2 a number line. What I told, root 2 is the irrational number. Before this, you know how to draw the number lines. Root 2, that means square root of 2. So 2 can be divided in two parts, 1 plus 1 whole root over. Students, you remind the Pythagorean theorem. What Pythagorean theorem? If ABC is a right angle triangle and your O is 90 degree and OB is the base of the triangle, OA is the perpendicular of the right angle triangle and AB is the hypotenuse, then h square is equal to b square plus p square, or a square is equal to p square plus b square, the same thing, and h is equal to square root of p square plus b square. So how can we follow this rule to locate root to a number line? Let this is your graph and this is your x-axis. It is x and x dash, and this is your y-axis, y and y dash. Let it be your origin O. Take one unit OM on the x-axis and draw 90 degree here and go through OY as 1 unit. Now YM, it is your hypotenuse. So this equal to 1 square plus 1 square, because p square, this is your p square and this is your b square, it is your a square. 1 square plus 1 square is equal to 2. Then root over of 2, it is root 2. So now draw the arc of root 2 and this will intersect OX on the point M1. On the point M1, that means this measurement YM is equal to OM1, though we had taken YM as the arc distance. So OM1 equal to root 2. In this way, you can draw root 2 on the number line. Root 3. How can we draw root 3? Here we get root 2. Now take one unit here what? The same measurement OM1, you will take 1 unit here. First draw 90 degree by the help of the rounder and pencil. Draw 90 degree. This is 60. This is 60. Bisect it. You will get 90 degree here and take the same measurement 1 unit on the y-axis. Now this is root 2 and this is 1. What you will get? Root 2 square plus 1 square. Now join this one. This is your root 3. This is your root 3. O y1. O y1 is your root 3. Take the same distance. In this way you can draw. Take the same distance 0 to y1. Are you clear? This measurement you will take the measurement of the hypotenuse and draw the arc in the same way. And draw the arc in the same way. What you see? Here it will intersect OX on a point. Are you clear now? So this point where it intersects, see, put the dot marks, dot marks, dot marks. In this way it will intersect here. It is your M2. That means OM2. OM2 is your root 3. Are you clear? In this way you can increase. You can increase as root 4, root 5, root 6, root 7, root 8, root 9. In this way you can find the root values and you can locate it on the number line. Are you clear, students? So any number, if anybody will give you to locate on the number line, then you can also draw. Find the decimal expansion of real numbers. You know 10 by 3, this is a rational number and every rational number is a real number. So now what is the decimal value of this rational? 10 by 3 means divide 10 by 3. We divide 10 by 3. 3 3 is a 9. 1 reminder. Put decimal here because 1 is less than 3. Now put 0. Though you put the decimal here, it is 10. 3 3 is a 9 again. Then reminder 1. 0 continue. 3 9. Then 1 0 continue. If you will continue this process up to infinite, then this process also will be continued. And here 3 is recurring. 3 is recurring. That means there is not reminder as 0. So it is not terminating. What do you understand by this? This is not terminating because there is no end of the division. When we cannot find the end of the division, that means when we cannot find the remainder as 0, that is non-terminating, and the number 3 is continuing, so it is recurring. So this real number 10 by 3 having its decimal value as non-terminating recurring. So we can write it as also 3.3 recurring. But here I put the but. That means these 3 after the decimal 3 is continuing. 3 is continuing. Are you clear? Then come to another real number 7 by 8. Take it as example 1 and take it as your example 2. 7 by 8. This also very easy to divide. So divide 7 by 8. 7 is less than 8. So put 0 here and give the decimal value here. 0 point. Then 8 is 64. 70 minus 64 is 6. Put 0. Now it is 60. 8 7 are 56. Now remainder is 4. Put 0. Then 8 5 are 40. Here the remainder is 0. What we get? The remainder is 0. That means 7 by 8 is divisible by some step. And we get the remainder as 0. When we get the remainder is 0, that is terminating. This decimal expansion of the real number is terminating. This is the terminating number, and it is the non-terminating recurring decimal. It is terminating decimal. Are you clear? So we will one thing remember and remind, whenever we will get non-terminating recurring decimals, they also can be expressed in rational form. They are not irrational. They can be converted into rational form. Are you clear? So we will go through that, how the non-terminating recurring decimals can be converted into rational number. Suppose the number 2.3. Let 2.3. This is a non-terminating recurring decimal. What I told, this is a non-terminating recurring decimal. Then let it be x. So 2.333. Continue. This is your x. And then 10x equal to how much? Multiply 10. 23 point. When we will multiply the decimal number with 10, just take the decimal number right side. After one number 2, then 23.3. 3 also continue. So now subtract 10x minus x. 10x minus x. This equal to 23.3 recurring minus it is 2.3 recurring. 10x minus x is your 9x. It is your 9x, and this is